So, good morning or good evening, depending where you are in the world. So, second day of the lecture about the hands-on training on data analysis. Just to briefly recap what we had yesterday. So, we started from this pipeline. That is the first one we discussed in NIME. I remember to you that basically with the data preprocessing workflow, we discussed at the end of the lecture how to realize this matching function, while the second workflow was mainly related to this second part, but without this explainability. Okay, so this was the first one that was realizing preprocessing. Here is already clarified. The preprocessing was realizing the fitness matrix starting from separate files already preprocessed to have agreement between description of competencies, skills, knowledge for the candidates and for the job offers. Then the NIME workflow number 2 was starting from the fitness matrix and was showing basically how to train the Lambda Mart machine learning model to learn the scores and how to obtain the top K candidates, evaluate the performance, and for those that just joined, I'm making a short recap of what we had yesterday, evaluating the performance and measuring also the statistical disparity. Then after that, we introduced with the workflow number 3 this workflow, again without contribution yet. So starting from the matching function was excluded, sorry. Starting from the fitness matrix, we first saw a methodology, the learning fair representation method, to turn the data representation into a fair version with respect to a sensitive attribute. Then we trained again the machine learning model, our Lambda Mart model, and we obtained again the scores, the top K candidates, the performance as an histogram of normalized discounted cumulative gain, and the statistical disparity that was reduced with respect to the other versions. Okay. So today we see how to realize explainability. So again, we will start from the fitness matrix, as the other thing is part of the preprocessing. Okay, and we will focus now on how to get these contributions through one of the most widely used explainability technique that is named SHAP. Let's see what they have in the slide. Okay, yes, just a short overview or recap on SHAP that should have been presented like other methods in the theoretical lectures. This is one of the possible visualization of SHAP through breakdown plots. So let's start from the end. Let's start from the result. What is the result returned by SHAP? Basically, with SHAP you have, in this plot is harder to read which is the baseline, but I get it is 0. It is 0.35. But here it's hard to read the final result, so I will give you the result directly from the final graph we have here in the workflow, because it's easier to understand. So let me take this visualization here, and then we will reach this final goal. Okay. So basically, in this case, well, also in this case, the baseline value is not very clear. We can guess it is 0. So, sorry. So, the result of SHAP is a set of feature importances for the prediction of a single record. So let's imagine we have a single candidate that have been analyzed by the machine learning algorithm for a single job, and for which we have a score that will provide the ranking. Basically, what we have is how much every feature of the candidate has a positive or negative impact in its final score. Okay, so for instance, in this case we are observing here, we see that education has a negative impact of -807, so a very big positive impact, very big negative impact. Okay, and you can see on the left all the features having a negative impact. Also languages is negatively contributing, as well as experience. And we have a small negative contribution with respect to competencies. On the other hand, the other attributes, age, gender, contract, nationality, and knowledge, have a positive impact. More or less all the same positive impact for ranking, for age, gender, and knowledge, and small positive impact for nationality and contract. So the explainability can be used for many purposes. So we can see how the machine learning model is reasoning, which are the attributes which are more important or less important from a local perspective, meaning for a specific candidate analyzed for a specific job, and can also be used for the biasing purposes. In this case, we can see that the gender is positively contributing. Okay, so it's increasing the score of this candidate that might be not good for our policies. Okay, because we want to avoid a decision making that is based on sensitive attributes. Okay, so this is more or less the same representation. Actually, SHAP starts from a baseline value that here I guess it's represented by this black line, that is 0.35. That is more or less the average score that is received by any candidate for any job. And then these various features here are augmenting or diminishing the score of the candidate. So in this case, if I'm reading this plot that is not conventional, but at least has the features we are interested in, we start from 0.35 and in the end we reach 0. It means that the lack of years of experience, the lack of education level, the lack of previous employers, the lack of digital skills in a small part, and the lack of management skill are making decrease the score of this candidate for the job for which he or she applied, despite the fact that communication skills, problem solving, programming languages, and GPA are positively contributing. So here you can see with this formula that SHAP works in this additive fashion, starting from a baseline value, in this case it's this 0.35, and then we have the sum of the other contributions. Do we have a question? Maybe just someone that forgot the mic open. How are obtained SHAP values? So SHAP values are a sort of, how to say, approximation of Shapley values. Shapley values theoretically are the average marginal contribution of a feature across all possible coalitions, where with the word coalition we can consider the combination of mixed feature values. So to imagine SHAP, you can imagine that you are the coach of a team of players, and you must select the best team, the best players to win the game. And you have this possibility of simulating all the possible games with all the possible combination of players. So you fix some part of the team, you fix some players, and you change the others. In this way, you can observe the contribution of this fixed part. The fixed part can be a single feature value or can be a combination of them. Let's say the goalkeeper and the striker are fixed, and you change all the others with a football similitude, if you want. And you average the outcome you get having kept fixed the goalkeeper and the striker, and you see which is their average marginal contribution. The bigger it is, the more important they are for winning the game. And in this case, translating in our setting, the bigger are the contribution of communication skills, programming languages, GPA, etc., the greater it's their importance to obtaining a certain score from the machine learning algorithm. So now I'm going to show you from scratch the workflow, and then in the same fashion of yesterday, you can play with the workflow to put hands-on and better understand it. So let's start again from the beginning, okay, such that we revise all the nodes. So as I was mentioning yesterday in the last session of questions, so NIME is just a possibility to realize this workflow. In reality, can be done in many ways. So NIME is a possibility. I have to say it's quite a didactic tool, even though for some application can be used also for real, but there are systems which are similar to NIME but much more powerful. As an alternative, you can use programming languages like are doing our friends programmers in parallel with us. But more likely, this workflow that here, thanks to NIME, we can visualize at once in a single dashboard, it is maybe realized as a composition of different softwares for the different phases, okay? So again, we have the CSV reader, okay? CSV reader that is reading our fitness metrics 1, same as yesterday, exactly the same. And then we have the CSV reader that is reading, I prefer to read the unfair score. Okay, we are reading the unfair score. Then the joiner, I will go through it as yesterday we had some trouble. We need to pair the row ID, curriculum ID, and job ID to be sure that every every candidate job evaluation is matched with its candidate job matching fitness matching results. Let's say the result of the pre-processing we discussed yesterday at the end. So we need all these three. After that, we must ensure that the dataset is sorted by job ID. So here we have the dataset coming out from the joiner. We see the dataset. Then the lambda mart algorithm requires that the algorithm is sorted by job ID, okay, and therefore we sort our dataset by job ID, and to be sure that everything is always sorted in the same way, also by curriculum ID. Now in this workflow we don't have the fairness correction phase, okay? That will be your job in the case study. You will be asked to realize the entire workflow, okay? Putting together all the pieces. Tip, cut and paste works. So you can copy a node and paste, okay? Also from one workflow to another. And you can also copy a sequence of nodes and cut and paste them. Either you do Ctrl+C, Ctrl+V, or you copy here like with right click and you paste. Okay, end of the tip. Going back to the workflow. So training and test set split, row splitter. We split the dataset into training and test set. Like yesterday, we keep 160 job offers to train our model, and we use the remaining of them, which are 40. I remember here when there is more than one output port, you will have multiple access here. You see, now I have selected the row splitter, so I have access to the output of a row splitter, and I have two outputs. Filtered, that is the top port, and filtered out, that is the bottom port. If I click on sorter, I have only one output, that is the sorted table, okay? Names are assigned automatically by name. So row splitter, the upper part is the training set, is connected to lambda mart. It's the same as yesterday, the lambda mart learner, and here we have the lambda mart predictor. Light green models which are learning something, dark green nodes are applying a model, and through the gray box here we make flow a model. So black arrows are making flow the data sets, gray arrows with the boxes are making flowing models, and they must be of the same type, obviously. So once you have the lambda mart predictor trained, you can evaluate the performance. Here it is not done, so I will do on the fly. We evaluate the performance by observing the where it is. I can show you the cut and paste strategy. I copy the histogram from here. Copy. I go here. I want to have this node also here. I paste it. And then I connect it. And I can see the output. Now there is nothing because in this case we have something different from before. Now I remember. indeed, we should see what is coming as input to the lambda mart predictor, okay, that is different from before. So in the previous workflow, the one we had yesterday, we were passing to the lambda mart predictor here. No, this one. That is simpler. We were passing to the lambda mart predictor, the bottom port, the entire test set. You see, we have this black arrow connecting the row splitter that is separating between training and test to the lambda mart predictor. Okay, and after that we had access to the histogram to observe the distribution of the performance for the various job offers. But now we have something different, because the lower part is going into this box of explainability that we need to discuss now. Okay, so how does it work? So first we have a row filter that select a specific job offer. So this is to specify that SHAP explanations are local explanations, okay, meaning that they are unveiling the feature importance for a specific job offer and for a specific applicant that is sending the CV for a specific job offer. So the first row filter is filtering the data set with respect to a job offer. In this case, we use row filter, and in the matching criteria we use this filtering, use pattern matching. So it means that the column to test is job ID, and this should match 160. So after that, as output of row filter, we have indeed a data set that has as job ID only 160, but we have all the applicants for 160. We have only 40 rules. Here we can see that entering to this row filter, we have more than 3,000 rows, but exiting, we have only 40 rows, because we have only selected the pairs curriculum job offer with job offer equals to 160. Now we make an additional row filter, okay, here, an additional row filter to select a single candidate applying for the single job ID 160. So it's the same node as before. This time we test the curriculum ID, and I've decided to check what's happening for the candidate with this ID. And you see the output is indeed a single row. Okay, now we are in the setting that is decided by SHAP, that is a single instance to be analyzed. So to run SHAP, we need a sequence of nodes in a fashion similar to the one we had yesterday with the data preprocessing, but slightly simplified. So we have this node SHAP loop start, because we need to analyze the contribution of every feature. So this method here is going to iterate through these features to observe the final contribution. Okay. Then the SHAP loop start method also requires a second input. In this case, we use what's coming out from the raw filter selecting the job offer. This dataset is used to observe which are the possible players that we can put into the team, meaning the possible alternative values that we can change with respect to this record here. So this guy has education 1, age 0, gender 1, contract 0, nationality 0, competencies 0, knowledge 0, language 0, experience 1. And therefore, these values could be replaced by all these alternatives that are those of all the other applicants of job 160. This is a choice we made, but theoretically you can pass here the entire training set, test set data set directly from here, or the training set data set, or whatever you like. So the SHAP loop start is completed by the SHAP loop end. So these will automatically loop among the different variables. Okay. And we need some nodes here to make the calculus. First of all, we have this column splitter that removes the SHAP ID column that is added by this SHAP loop start node here in the end. Okay, these are the iterations that are going to be performed by SHAP, and this column must be removed before passing the node to the lambda mart predictor. Okay, so now here what is entering, it's a single it's the data, it's the test set of records, but this will be varied iteration by iteration, and this will be hidden from us. The output from the second port here, it is the prediction that is performed by the algorithm for all our alternatives here, but if you see them, there will be something that is different from what is really in the data, because these are the perturbed versions. Okay, so these are not the real data. So from the output, we filter out the curriculum ID and job ID, we keep all the rest, and we join this information with the joiner. Okay, the joiner, we reach the SHAP loop end. So basically this, okay, this node here is required to provide the correct input to the lambda mart predictor, while these other nodes here are required to manipulate the data set just as a technical representation thing to the SHAP loop end. Finally, the SHAP loop end is going to collect all the feature importance, and we will see that we will have a single record, as in input we had a single record, our friend with this ID applying for job 160. We have the various feature importance, and through the bar chart plot, we are going to visualize them, okay? Excluding from the visualization the features which are not part of the predictive variables. And here is the result that I have previously discussed. Okay, so Now, like yesterday, I'm going to create breakout rooms. So today there are 5 of us because Daniela is doing a parallel session. So I'm creating 5 rooms. Okay. Yes, go ahead with the question.
Hi, Ricardo. So, sorry if this is a very stupid question, but the thing I don't understand is, so if I have 3 different job requirements, I have 3 different roles, and for each of these roles, I have different requirements. So say, for example, for my legal team, I need more people with a particular expertise and specific language skills. And for my for the role of the truck driver, you know, I have different requirements. And then I have a third opening, and for that one, I have again different requirements. Is right. So is, I mean, I know we're using this particular model at the moment, but are the models clever enough to be able to work this out simultaneously for 3 different roles with different requirements, or do you have to do this every single time for every single role with requirements?
Yes, I got the point. I mean, this specific explainer shop, it's for individual explanation, for local explanation. So you must do it case by case, but you can run these things in parallel. So the process is independent. Now you can't do it with NIME because it's a sequential tool. But practically, you can analyze with the same workflow multiple cases simultaneously. Okay.
Okay, but how does it know? So how does it know what the population is? So how does it know what the input is versus what it needs to adjust to get the right output, or the right output, a fair output?
Okay, no, SHAP is not adjusting things. It's a sort of magnifier.
Okay.
It helps you to understand which are the features that were more or less important and with respect to which degree to get the final ranking, the final score. Okay? It doesn't change anything.
So can you hear me?
Yes.
Okay. Yes. Now you are asked to work all together, and because we would like to replicate the case studies we faced in the case studies part, the algorithmic discrimination in candidate selection. If you don't remember this case study, I will tell you how it works. There is a candidate who is trying to, he is a black candidate who is trying to apply for a job offer. And his application is always rejected. Okay, then what does it happen? He wants to know why his application is rejected. Okay. And what we want that you learn is to understand the difference between a fair score and an unfair score. I remember you that the ranking is performed with the list of candidates that are applying for this position, okay? And everything is based and compared to the score, which is our ground truth. Okay, without ground truth, we are not able to perform any analysis. Okay, we have to start from this ground truth. Okay, then what is our aim? Our aim is to compare the normalized discount cumulative gain, okay, and the statistical disparity metrics. Okay, between the two score. Our historical data. So I will teach you how the score is computed, is created, okay? And we will compare the score fair and unfair, and then we will observe the results. At the end of this explanation, we'll have the break, and after the break, you will be requested to work in pairs or in groups, okay? And to answer, to do an exercise on book lab, okay? And you should arrive to create the without looking at the screen, of course, in order to see if you understood what we explained to perform the analysis all together, and to create the pipeline of the actions that are requested to arrive to the final results without looking at the screen. But I will show you the exercise later, don't worry. But this is very important to understand if you understood what we explained. Okay, it is a really simple exercise. Now I will try to explain the case studies. The case study, if I find it, yes. Okay, here we are in the case studies. So the workflow number 5 for the programmers. I don't know if you know KNIME. KNIME is a visual data analytics platform, and which makes use of nodes to perform the analysis. Every node has a particular function behind, and so let me show you for the programmers, just a moment. For the programmers, you can select the list of nodes from the left and simply drag and drop the nodes in order to apply a function to the data set. To read the data set, you simply have, so it's clear, you simply have to insert the path and everything will appear here. The execution of each node creates the results, and you will see the results here. Okay, you will see the results as soon as your mouse is over the nodes. Okay, so here we read the fitness metrics, here we read the score, and you see that the table changes. Here we join, so the word is the same, like a join, while in internal join is performed between the fitness metrics and the score. Okay, so for programmers, we have a pipeline and we have a number of annotations, so the colored square that tells us what this node is computing. Okay, so here we read the data set, here we sort the values by QID, here we split the train set and the test set, so it's the split train test, and here we have our algorithm, the learner, so everything is behind. So this node has been implemented to perform the lambda mart learner, and the result is the model. Okay, and here we have the predictor of the lambda mart. Okay, so this was for programmers. Now, how the score is created, so our ground truth. First of all, I have to remember that the score is the historical data of a company. So we have a company and all the historical data, so our ground truth. The score can be fair or unfair. Why? Because for every company, we have a feature importance. So what is a feature importance? the importance that we assign to every feature. So for my company, for this job offer, for me, in a scale from 1 to 10, the education has an importance of 8. Since I'm a fair company, the gender has an importance of 0. What does it mean, an importance of this 0? This means that for every candidate, since I can be male or female, if you multiply this feature importance for 0, 1 for 0, and 0 for 0, the result is always 0. So this is not important because every candidate will have the same, always the same result. Okay, so the importance is 0. For instance, my level of education is 2, and the feature importance is 8. 2 multiplied by 8 is 16. If my level of education is 4 and the importance is 8, 4 multiplied by 8 is 33. So the double of is 16. Do you understand what the feature importance is? This is the weight of my final score for every feature. So if the feature importance is 0, everyone will be considered at the same level. Nationality 0, because I'm a fair company. So if you are Chinese, African, European, for me is the same. The age, I was explaining that before, there can be a difference. So there can be jobs that requires a minimum level of age. So I can be 16, for instance, or for instance, in America, you can be 16, but not in Europe. Okay, so there can be a difference. The contract for me is not important because if you work remotely, if you work in presence or an hybrid, for me is the same. Okay, experience the same, languages, competencies. For me, competencies are very, very, very important, and knowledge 8. And I'm considered a fair company. Pay attention to the fact that gender and contract are bold. Okay, so we will came back later to this aspect. Okay, unfair. Are there any questions up to now? Is everything clear? Okay, then I'm at a society and I'm not fair. I'm unfair. The education is 8, the gender is 0. Oh, but we said that if gender is 0, this means that this is not important. Okay, correct? But because everyone will have the same results. Is it correct? Yes. So we have 0, and nationality is always 0. So I'm a fair company. Yes or no? Yeah, but pay attention, contract is 8. This is called redlining. What does it mean? This means that we can have a gender, so a sensitive attribute, which is 0. So every candidate will be considered in the same way, but the gender is correlated to another attribute. And to make you understand, we correlated our data to the contract. What does it mean? This means that the majority of female applicants have, or in their CV, a remote contract, whereas male applicants have in presence. The system will learn that all female, even though the gender is not important, we learn that all female applicants have remote, and all male or female or not, and no, not binary, so not male, and all male will have an in presence contract. This is subtle. So this is not clear because the gender, the feature importance for the gender is 0, but we have, since this feature is correlated to another feature, this correlation will be learned by the system. And you will see how this changes the final results. So look at this. Sorry. Look at this. Okay. We have a fair company here. We apply our algorithm, our ranking algorithm up to the end, and we calculate as before the statistical parity. We learned to calculate it yesterday. What we have at the end, so I go up to the end, and here we have a bar chart, and we can see that not male are more than, sorry, that male 0 are more than not male. Okay? In our final results, we calculate the statistical disparity, and this level should be very, very, very small in order to have a balance. Yes. This is dataset FAIR. Okay, sorry, I repeat it. Yeah, because I repeat. So here we should have fitness matrix 1, okay, and then you can play with that, and dataset score 1 FAIR. I will check. Give me 1 second. Okay. Okay, and at the end, okay, so this is fitness matrix 1 and score 1 FAIR. Okay, at the end, what is our statistical disparity, Andreas?
Yeah, just one question. Are there,
yeah.
Is there the same number of male applicants than female and non-binary?
No, so we will see it here. So here we have, I didn't focus on this analysis because you performed it yesterday. So, but I will show you. So like to review some aspects. So here we selected the top K applicants. Okay, top K for us is 10. So out of all the applicants for this job offer, we want to know only the top K, so the 10th up to the 10th position, okay? And for male, we have 215 selected out of all the applicants for this job offer, and not male, 185, okay?
Yeah, but my question was right at the very beginning, before any selection has been done.
Okay.
Is there a parity between male and female and non-binary? Because if I have like 80% male applicants and just 20% female, it's clear that the outcome would be then skewed towards it.
Okay, so we will see in these other. So these are the numbers of applicants. These are the total number of applicants. And you can see, as soon as I show you the results, that we have less male than females, okay? Females are not binary. So we have 472 male applicants and more than 2,000 of not male applicants, so female and non-binary, okay?
Mm-hmm.
How many of them are selected? As soon as you see here, you can see that there are more male than female selected, okay? Despite the number is completely the opposite. If we go up to the end, we can see that the statistical disparity, however, is little, okay? What is the statistical disparity? We see it before, is the difference between the two proportions of not male selected in the top K and male selected in the top K. So here we have a small, this value should be small. And because our data set, we say that our score is fair. Look at that. So here we have an unfair feature importance to calculate the score, but this is not so clear from the beginning. Why? Because the gender is 0, and so we can say to whom? To the so for instance, for to systems that are, or companies that are verifying if your feature importance is fair, if your score is fair, if your company is fair, and you show that you consider the gender as 0. So you can state that your company is fair. So the question is your company really fair? Or there can be a correlation between your gender and another feature in your feature importance. If we see the results, so here we use the same data set, fitness matrix 1, and the unfair score, which is computed with this feature importance. So the gender is always 0, so I can assume that I'm a fair company. However, this red lining, so something that is subtle, that is under the truth, tells me that the contract is 8. This is the unique values that changed, okay? Because here we had 0 and the rest is completely the same. We didn't move anything. We didn't change anything. Okay, here, the only aspect that changed in this unfair score is the contract. If we go up to the end, okay, so here, the number, look at that, the number of male applicants selected in the top K is almost 400. And the number, we didn't change anything in the workflow, in the pipeline. Any parameters you can really check for non-programmers, you can check all the parameters are the same. We simply change the correlation with the contract. Okay, and here you can see how this number changes. So before I go up, this number was 215, and almost the same. So there can be a difference. It depends on the curricula that have been submitted. Okay, so this can be a different because of the type of curriculum, but the same curricula, the same algorithm parameters, they are all the same. What does it change? The score. Okay, and the score of gender, the feature importance of the gender has been correlated to the contract. For you, oh, the contract is not important. For me, if I work remotely, if I work at home, is the same. But to make you understand, we correlated the contract to the gender. You don't see it because the gender is 0. So you can assume that you are a fair company. If you look at the results, here you have, with the same curricula, the same algorithm parameters, the same, everything is the same. You have almost 400 male people that have been selected. The number of applicants is always the same. So look at that. Applicants, here, applicants, here, the same, selected in top K, 200, and here, 400. At the end, what do you have? A statistical disparity, completely different. Okay? And this is very, very, very subtle. This is slightly different in the contract, but the system learns that there is a correlation between the gender and the selected contract in the CV. And this can be considered a very discriminating result, even though as a company, I can assume that I don't consider the gender because the gender for me is 0. Okay, is that clear? Is that clear? So this is really an example of how the score can discriminate candidates, even though the appearance is completely different. We say the gender isn't important for me. So any of you can be enrolled, but since there is a correlation between the gender and any other feature, we use the contract to make you understand, but it can be with other features that are requested in my job offer from my company. You can see in this example how the final ranking can be discriminating, how the final ranking can be applied with an appearance of fair company. Are there any questions? Yes, Andreas. Sorry, I wasn't aware. Yes, Andreas?
I think Jazz was the first one.
Yeah.
Who had a question.
Okay. Yeah, shall I go first? So my question really, Daniela,
Yes.
a very non-programming question, but you've used the algorithm Lambda Mart, so I saw that was kind of the funnel, but have you tested this using a different algorithm to see if you got the same result?
This is one of the algorithms that we implemented, but this is one of the most used in the ranking. We, in our project, not for this course, but in our project, we are testing other ranking algorithms, and the results are always the same because there is a correlation. Yes, the correlation between, in this data set, between the gender and the contract. And many companies can play on that. Okay, so this is to make you aware of an appearance of anti-discrimination behavior. So a fair feature importance can, in fact, hide a discriminating feature. So this is really clear, okay? So the only thing we change in everything, is the feature, is the weight, the feature importance, the weight of the contract. And it wasn't clear from the gender. So for me, the gender is not important. I can assume that I'm a fair company. So I can say, oh, I would like to hire all genders, okay? But it's not true, because the gender is correlated to, can be correlated to another feature, which is not so clear, because it's not a sensitive attribute. The gender is sensitive, but the gender is 0. Okay, the gender is 0, like in the fair. No questions. Julie, are you inside? Okay, because I always receive this message. Are there any questions? No questions? No questions? No questions? Okay, break. We can, Andreas, yes.
Just to check whether I understood this. I assume that then in the raw data, there must have been the majority of the female applicants actually wanted to work remote, right?
Exactly.
And that's why there is this correlation. So another example, the classical example would be part-time or full-time.
Perfect.
The same, right?
Exactly.
Yeah.
Is that exactly?
Daniela, show the slide, the last slide.
Yeah. Yes. Okay, here. Do you want to explain it, or Salvatore? Yeah, go ahead. So
yeah, you can see from this slide that we injected this correlation in the unfair data. Majority of female have contract 0, and majority of non-binary have contract 0. Instead, the majority of male have contract 1. And the example you made about part-time is another typically correlated feature with gender. So in our synthetic data, we injected this, but in reality, it's much even more complicated.
And my question is, there might be many other features that are correlated to some extent, right? And that makes it then in the end very difficult, because it could be job experience, since women probably are more often the child carers and don't have so many years of service. So that might be a correlation too, or whatever other feature there is. So in the end, with this program, you can find out correlations, right? I understand, between protected features with protected features probably, but in the end, the solution might be difficult in some.
Yeah,
cases,
the fair preprocessing algorithm was intended exactly to find out and decorrelate all or the most evident correlations. So the fair algorithms are intended exactly to discover these a priori unknown correlation and they correlate the data. Okay. And it's not simple. You are right.
Thanks.
That's why we are working in this direction. Yeah, for anti-discrimination in hiring, because a number of systems can hide this aspect that are apparently fair, but because their score it's apparently fair, but it's not true. Okay, that's why we are all here. Are there any questions? Other questions? No? Yes, Ivor.
Yeah, thank you. Yeah, very nice funding. Oh, yeah. Go ahead.
My question. Mm-hmm.
Yeah, my question is how has been taken on board by industry? How has the recruitment industry and big players involved in big software players like Salesforce, how have they taken this on board? Are they keen on this type of work, or?
I didn't.
Yeah.
Sorry, but I didn't understand the question, Salvatore.
Yes, the question was whether the industry from the sector has been involved in this research. There are two aspects. From the research aspect, novel proposal of fair models are tested against available test data sets. And this data set may be in collaboration with players of the sector. The second aspect, but this is for the moment minimal collaboration. The main point is since the starting of the AI Act, the screening is considered a high risk application of AI. So company will be forced to do this kind of analysis. So the game starts now, actually.
Thank you.
I suppose there was another question. No? Okay. Yes. Yes.
Yeah, I think I got a maybe similar question about the data sites, because I suppose that for companies, maybe they are not willing to share the data, right, with you, because you want to, pick up some kind of discrimination bias in their data sites. So my question is, how did you get the data sites? Collaborated with them or in some ways?
So concerning the CVs, we have our generator for synthetic CVs, but if you look in the FINDHR site here, we have a call for action: donate your CV, and we collected a huge number of CVs, because the FINDHR project is not only this training course, but we are as you can see here, we are a number of university and companies that are working in this direction. Okay, and so we are collecting CVs in order to analyze the results of our algorithms. So this can be a starting point. And in order to train at the very beginning our algorithms, we use this synthetic data set, not the only one that you are using for the course, a more complex one. So the course was really, the synthetic data set we used for the course was really simple in order to make you understand the main points of the analysis of this pipeline. But we have a number of CVs and job offers that we are analyzing in real scenarios. And this is only a small part that you are looking for, that you are participating in.
Thank you.
You're welcome.